Calculating the hydrogen deficiency index, or degrees of unsaturation, can help us come up with the proper structures. So, saturated compounds have no double bonds and no rings. They have as many hydrogens as they can take. They're saturated with hydrogen. And they're always going to have this formula. You're going to have a hydrogen on the end, a carbon. Each carbon will have two hydrogens, and then there's a hydrogen on the other end. So if we've got this compound here, we have, I'm going to change colors and we'll just draw in hydrogens. Nice Christmas colors here. Okay, so there would be two hydrogens on each carbon. And then the ones on the end get a bonus hydrogen. We can get to draw it. There we go. Our bonus hydrogens are thicker. Okay, so we get this formula here. Cn, whatever n is, you're going to have 2n plus 2. Okay, so the number of carbons times 2 plus 2 will be the number of hydrogens you need to have a saturated compound. Now, unsaturated compounds are rings, alkenes, alkynes, and they have fewer hydrogens. So here we have a pentene, and it's got 5 carbons, but instead of 12 hydrogens, it only has 10. Here we have an alkyne, also 5 carbons, but instead of the expected 12, we only have 8 hydrogens, and so forth. Also occurs with rings. With 6 carbons, I would expect to have 14 hydrogens. That's 2 times 6 plus 2. And instead I've only got 12. You can count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so if we have 1 degree of saturation, the compound is missing 2 hydrogens. So you might have a double bond or a ring. With 2 degrees of saturation, you're missing 4 hydrogens. Perhaps you've got a triple bond, or you could have 2 double bonds, or you could have a ring and a double bond, or you could have 2 rings. So to calculate this hydrogen deficiency index, we count halogens as if they were hydrogens. Each halogen will replace 1 hydrogen. So C2H5Cl has the same hydrogen deficiency index as C2H6, the chloroethane and the ethane. We just replace. Oxygen does not affect your hydrogen density, your hydrogen deficiency index. Okay, so ethanol has oxygen stuck in here, but we still have the same number of hydrogens. Nitrogen will subtract 1 hydrogen. So here we have ethylamine. If we stick a nitrogen in here, we get a nitrogen and 2 hydrogens, replacing the single hydrogen. So this is the formula that you're going to need to know. The hydrogen deficiency index is going to be equal to 1/2 2 times the number of carbons plus 2 for the n hydrogens. If there's a nitrogen, we add 1 for each nitrogen, and then we subtract for the number of hydrogens and for the number of halogens. And I think I've already gone, we talked about this just a minute ago. Okay, so here we have a fairly complicated molecule. We've got 4 carbons, 8 hydrogens, a chlorine, a nitrogen, and 2 oxygens. Our hydrogen deficiency index is going to be equal to this formula. It's the same formula I just went over. It's 1/2 times 2 times 4. 4 is the number of carbons, plus 2, which is part of the formula, plus 1, that's for the nitrogen, and minus 1, I've got this. Okay, so let's look at this. We've got 1/2, 2 times the number of carbons, that's where the 4 there comes from, plus 2, that's in our formula, plus 1, that's for the nitrogen, minus 8, that's for the hydrogen, and minus 1, that's for the chlorine. And we end up with a degree of saturation of 1. So let's do some of these examples fairly quickly. We'll have A. We've got 1/2 time, and we're going to have 6 carbons. So we've got 6 times 2 plus an additional 2 for the N hydrogens minus 10. And that's going to give us an unsaturation of 2. Here we've got 1/2 of 6, looks like 5 times 2 plus 2 for the N hydrogens. We've got 10 hydrogens, so we're going to subtract off 10. The oxygen here is irrelevant as far as figuring out our score, and it will be 1. For the next one, for C, we've got 1/2. We've got 5 carbons, and we have a nitrogen. So for our nitrogen, we're going to have to add 1. And it looks like we need to subtract off 9 for our hydrogens. And we should get the answer 2. For D, we have 1/2. We've got 3 carbons. We've got 5 hydrogens. And we've got 1 halogen, the chlorine there. The oxygen isn't going to make any difference to our deficiency, so we don't put that in. Make sure I get the right one. That's 1. E, we have 1/2. We've got 10 carbons times 2 plus 2. We have 20 hydrogens. We subtract 20 off, and we get 1. F, we've got 1/2. We have 4 carbons. We have 6 hydrogens we're going to take off. We're going to take off 2 for the bromines. And we'll end up with 1. And that ends the chapter.